right. So, good time of the day, ladies and gentlemen. Today we are having a webinar session around Dynamic Resource Balancer service, the new bright and shiny service which got recently introduced into Mirantis OpenStack for Kubernetes.
Considering a cloud transformation or migration? Check out the Total Guide to Private Cloud from Mirantis to learn how open source cloud on-prem gives you cloud benefits without the downsides. Download now at mirantis.com/privatecloud.
And let me start with a quick introduction of myself. I'm Artem Andreev. I'm a staff product manager at Mirantis, specifically responsible for OpenStack line of products, on virtualization in general. Today's agenda. So what kind of topics we're going to cover today? So first of all, we'll make a short stop on the problem that we're solving with this new dynamic resource balance feature. Second, since we're kind of positioning the new service as an equivalent of VMware vSphere dynamic resource scheduler functionality, so we probably need to do a bit of a comparison about, what this or that thing does and how they actually could be compared in the first place, if at all. We'll have a quick deep dive into the architecture of the new dynamic resource balancer service. We'll talk about the availability, so basically when this service is going to become available to the wide audience, and some future plans like around the improvements that Mirantis is looking to introduce into the new service going further. Also, we'll be seeing a short demo of how the new functionality works, in practice. So first, what is the problem? What is the problem we're trying to solve with our new dynamic resource balancer service? It kind of narrows down to two types of customers, two types of requests that we are getting. So first of all, as you all probably know, a lot of companies are looking to move off VMware vSphere because of the recent acquisition by Broadcom, because of the prices going high, and obviously they're looking for alternatives. And so, of course, Mirantis is quite a noticeable player in this field, in the virtualization field, private cloud, is getting a lot of traction and a lot of communication with such companies. And one of the common topics in such discussions is okay, guys, can you actually build an open source based vSphere, but for a lesser price, and let us work with it just like we are used to? Okay, yeah, of course we can, but there is a certain piece of functionality which hasn't been there before, like in the open source and OpenStack in the first place. And this piece is called Dynamic Resource Scheduler service in VMware. So a lot of customers, they say, our vSphere cluster has this service enabled. We believe it does a great job at saving us money. And actually, if we were to move from VMware to OpenStack, we would definitely need to have such a service in our new infrastructure. Okay, that's an interesting kind of a request, and definitely we need to delve deeper into what this actually DRS means in the first place, what things it does that are so valuable for cost optimization. And we'll cover this topic going further, naturally. So second type of common request that we're getting is from people who are pretty used to OpenStack. They know how to work with it. They have quite extensive OpenStack environments already, running a lot of production workloads, and lots of customers, lots of VMs there. And at some point, every OpenStack cloud might start to experience problems with the certain hypervisors getting too hot, getting too many VMs, too much CPU load on them. And this creates a lot of problem for the VMs themselves, because obviously if somebody steals your CPU time, you're not providing a good service eventually to your users, right? So, and they do a little bit of a lookup on the internet. They say, okay, guys, I see that OpenStack has this nice and shiny Watcher project. Why don't you just have this supported in your distribution? And we believe it's going just to work as a charm, without any problem, and help us move things around just probably vSphere DRS does or something like that. That's a good request. Also, of course, we'll also need to take a deeper look at this as well. Like, okay, why OpenStack Watcher is not a solution from Mirantis perspective, and we'll talk about this also going further. Comparison. So on the left side, we have Mirantis OpenStack for Kubernetes, our modern, bright and shiny OpenStack distribution with its own, lifecycle management tools built around core OpenStack, with login, monitoring, alerting tools, all kind of operational things that you need to have if you want to run a really kind of a reliable production large private cloud based on the open source technology. On the right hand, we have VMware vSphere, and specifically the dynamic resource scheduler component of it, which is, well, pretty commonly requested as we figure out. Thing is, the very first thing to point out, well, there is no apples to apples comparison in this picture, right? So MOSK, Mirantis OpenStack for Kubernetes, or MOSK as we call it, has a lot of components because it's built from OpenStack, which also has a lot of components in it, which every component is playing its own function or component or service, right? While DRS in VMware is rather a monolithic thing, which is a big, so to say, combine, which does a lot of different functions at the same time. But still, the functional parity in between these two solutions, we believe it's like 99% there, well, of course, with the introduction of our new dynamic resource balancer service. Let's take a deeper look here. Okay, so what DRS does? Of course, it helps you when you create a VM, when you're trying to plan to create a new VM, right? It helps you place this VM in the most optimal way. So it basically gives you recommendations to which hypervisor the VM should go in order for the average load of the cluster to be level. Well, it obviously takes into account the overall load of the cluster, so it tries to maintain the balance. And well, if there are certain service levels defined for specific VMs, of course, it makes sure that, well, these SLAs can be met. Pretty cool stuff. Well, on the other hand, in OpenStack, there is a compute service, or we call it Nova, OpenStack Nova, which does exactly the same thing, right? But, well, with less interaction with the user, of course. You just say, well, I want the VM, and I want this VM with these and that characteristics. And Nova figures it out for you where this VM should go. So you almost don't need to worry about that. So this initial day one phase is pretty well covered with OpenStack already, without any additional development required or configuration. Yes, what else? What else DRS does? Well, it helps to move VMs around when you're doing a maintenance of your cluster. So basically, it knows what hypervisor is going to be taken into the maintenance next. It moves all the VMs that are running this hypervisor to different places so that, well, the continuous the workloads continue to work. And of course, well, it helps to collect and aggregate some metrics, some information about, well, what actually the cloud state or the clusters, vSphere cluster state is, right? Basically, how loaded are the hypervisors? Are there any imbalances? Things like that. In MOSK specifically, so this function is implemented as a combination of two major components. So our advanced lifecycle management system, which is an external thing to OpenStack itself. It's something that Mirantis has as a know-how, right? And the login monitoring alerting system, aka Mirantis StackLite. You go into hear this name once a few times more going further, right? So these two systems, they work together to help the cloud operator ensure that his VMs are not going to be affected by the maintenance and rather will be seamlessly moved somewhere else. What else? What else does DRS do? It helps to handle the failures in the cluster, right? So if some hypervisor is experiencing problems and, well, worst case, it just goes off, of course, things happen, right? It helps to move the VMs to different places so that they keep working there. In OpenStack world, in OpenStack ecosystem, there is a project or service called OpenStack Massacre, which is exactly implementing the instance HA feature functionality. Pretty the same behavior. Basically, if one of your compute nodes, and a compute node is a special term in OpenStack which designates the hypervisor, right? If one of your compute nodes goes down, an OpenStack Massacre will know about this and will make sure that your VMs get recovered in a different place on one of the suitable hypervisors that are functional. We can see that the parities here is pretty much in place. The most interesting part of DRS is automated load balancing. There we go. That's the decent parcel of the new service that we're talking about today. What that means, right? So yeah, it means continuous measurement of the status of your hypervisors in your cluster and making decisions that, well, the placement of the virtual machines needs to be adjusted in order for the optimum, quote unquote, optimum to be achieved. That's what DRS does. And that's unfortunately what OpenStack is not really, it's not capable of doing that at like really big production at scale for like, in real life. Everything else, like OpenStack Watcher, we rather consider like as a, experimental thing, which requires too much polishing, which would require too much polishing to make it like really work for real clouds. And that was the reason why Mirantis decided that we should create our own service, and we specifically call it Dynamic Resource Balancer to emphasize that it only implements one of the functions of DRS, and which is automated load balancing, and well, but does exactly that and does it well. On the footnote, actually, DRS does a bit more than that. There is an interesting functionality which I personally have never heard of being actually used. It's the power consumption optimization. It has something to do with like, shutting down unused hypervisors and like, moving the VMs off and then powering them back up once back on once there is a higher demand in the cloud. Pretty like elastic hypervisor cluster. Unfortunately, MOSK doesn't have anything like that. Well, at least yet, right? But we'll definitely be looking into this going further. But again, today's discussion is around the dynamic resource balancing functionality. Let's take a deeper look at the architecture. What is in there? Why it is so interesting? What can it do? What can it not do? One important thing to mention before we get dive. Mirantis OpenStack for Kubernetes is called specifically for Kubernetes, has this for Kubernetes part in the name. Why? Because every service that you're running is a pod in the underlying Kubernetes cluster. So basically, we have bare metal nodes, we have Kubernetes cluster deployed on them, and all the components of the cloud or control plane, data plane, they're running as containers, including the new dynamic resource balancer service. It is implemented as a Kubernetes operator and is controlled through the custom resources exposed in this Kubernetes cluster. Well, pretty much all the lifecycle management in MOSK is happening through this such interfaces. So it's a pretty common thing for MOSK operators to deal with kubectl command line or other tools like, for example, Mirantis Stance, which is a nice GUI for managing Kubernetes. Well, I will be actually showing a piece of it going during the demo. So what do we have? We have a dynamic resource balancer service, which is essentially a Kubernetes operator, which has three major parts in it. These parts are called collector, the scheduler, the actuator. So from the names, you can probably guess their functions. The collector aggregates the measurements from the hypervisors comprising the cluster. So basically, it reads the monitoring data. Well, in our case, in the default setup, that's Mirantis StackLite, our login monitoring alerting engine that collects this information and gives it out to collector. So collector does some data processing, like additional aggregations, grouping of the matrix, time slices, well, whatever you need to kind of have to get the data, whatever data you need to make further decisions, right? And the decisions around whether or not the status of the cluster is balanced or close enough to the optimum, so to say. And if not, well, what needs to be done about it? These decisions are happening inside the scheduler service, right? So it takes the data collected here from the collector and, well, does some algorithmic analysis of this data and, well, provides recommendations whether or not a certain VM needs to be moved away, migrated, actually, yeah. Well, we'll talk about migration later. In addition, this scheduler service talks to OpenStack Compute, or OpenStack Nova, as it is called, service, to its API to get additional information about the virtual machines, such like metadata. This metadata is used to make more precise decisions about moving the VMs around. Okay, so these decisions, after they're like finalized, they're handed over to the actuator service, which actually calls the OpenStack Nova API to initiate the live migration of the virtual machines from one hypervisor to another. So live migration means that all the CPU registers, all the memory, well, sometimes even the local block storage, it's getting copied as is from one hypervisor to another, just seamlessly. So ideally, such a VM doesn't even, well, the VM being migrated doesn't even notice anything. And most importantly, all these components, they are pluggable. They have this pluggable architecture, which allows you to expand their logic with your own custom, for example, decision-making mechanism, or your custom data collection mechanism to fetch some additional metrics or some additional pieces of data from somewhere else. Or if you're talking about actuator, it can be extended to not perform live migration, for example, do some additional, preparations before the migration happens, or some hooks, maybe you handle some notifications, whatever basically comes into your mind. How can one actually test it? Sounds all good, but well, how to get it? So the new dynamic resource balancer service, it is available already as a part of the MOSK 24.2 release, which happened on July the 8th, right? The status of this service is a technical preview, which means, well, that we probably would not recommend to go like straight into production, and would rather say that you should spend some time testing it first. But overall, it's functional, and well, it can be used against real workloads. So this service becomes available in all MOSK clusters, whatever you have installed by this time, or if you are going to install MOSK from 24.2 from scratch, you will get this service as a part of the package. You will, of course, will need to enable it specifically to do some configuration, and I'll show how to do that later for it to start working. But I mean, functionally, it's there. It supports the pluggability for collector, scheduler, and actuator components. You can add your own Python module, implementing your own logic. You can add it to the Docker image of the service, and well, all the scripts will start working as a part of the overall system. The service supports two major modes of functioning. So opt-in and opt-out balancing. What opt-in and opt-out means, that basically how the VMs are selected for optimization. Opt-in means that an instance is another term for like VMs in OpenStack world, that the VMs will be kind of handled by the DRB service only if they have this LCM Mirantis.com DRB tag assigned to them explicitly. It could be a cloud administrator or a cloud user who will be assigned this tag to his virtual machines. Or opt-out means that, well, the DRB would handle all the instances it is able to find, just without exception. Well, except except those that do have this, no DRB tag assigned. And that's the out is the default actually mode for DRB. So yeah, if you just provide an empty config, it will start picking up all the instances, all the virtual machines that you have using the cloud, and making decisions about optimizing them. So the default implementation of the collector scheduling actuator components, it implies that we're trying to optimize the standard deviation of the 5-minute average CPU load on the hypervisor. So basically, we're trying to make sure that this metric is almost the same across for all the hypervisors comprising the OpenStack cluster. Well, the decision making is built around the idea that the least loaded VMs need to be migrated first. And well, it tries to do this in parallel, just like in bulks. And well, you can specify the subset of the hypervisors that you want to actually DRB to optimize. This is possible through the configuration. You can create multiple configurations, one for each host aggregate, for example, for a group of nodes. It's really up to you as an operator to decide how you want it. And the default threshold, basically the limit which once hit by the target metric triggers the this line migration of instances is 80%. So basically, if the DRB sees that a certain hypervisor is running more than 80% load, it will go and look into this and try to move things around to maybe make it less loaded. There are, of course, limitations in the current implementation. That's what makes it one of the things that make it a technical preview. So first of all, well, it focuses on very simple VMs and very simple types of cloud resources, basically CPU, memory, or disk. Well, while in OpenStack world and in any kind of other virtualization platform, you would probably find advanced features like CPU pinning, NUMA nodes, SRV resources. That also needs to be handled properly while making the decisions to migrate the instances. So, well, as of the current implementation, DRB just ignores that. Well, if there is such a VM. It also doesn't doesn't take into account any kind of advanced configurations for OpenStack Nova scheduler service. It's like another scheduler, but in the compute service. Which handles the initial placement, if you remember, right? So there might be some additional filters or rules described. So DRB just ignores that for now. It assumes the configuration is standard, and all the scheduling is pretty straightforward. OpenStack scheduling, I mean, and it presumes that a VM can be migrated to any of the hypervisors it watches. Well, that's the trick. So basically, that means that you need to define this groups of hypervisors that you want DRB to watch, and you need to do this individually. It might be the case that a VM will not migrate from one host to another. Why? It might be what could be there. It might be the reason. The consequence of having different CPU models on these hypervisors, on the settings of the hypervisor. Well, all kinds of things. So usually that's something that OpenStack Nova or compute service handles. But as I said, DRB, as of the technical preview, doesn't take this into such advanced settings into the account. We'll address this going further, naturally. General availability. So when it's going to become ready for big production. The plan is to have the general availability at the end of this year or beginning of the next one. Yeah. So depending on how fast we're able to move with all this, so to say, improvements listed here. So of course, we want to improve the default logic. When we're collecting a lot of feedback from our customers who are already trying the service, we are learning how to like common rules, common expectations from the service, and well, of course, working on implementing these into the DRB logic. We want to improve the default scheduling of the VMs for it to take into account the metrics collected from the hypervisors. It's possible with OpenStack. You just need to feed the data from somewhere, like in our case, that's going to be StackLite, definitely, our login monitoring alerting tooling. And it will take the OpenStack Nova will take this data and make the best possible decisions around the virtual machine placement based on these metrics. So this helps to minimize the need to do the rebalancing of the cluster going further. The most exciting part of this whole improvement is to actually extend the compute service, right, with the new API. Remember I said that, well, it's not always possible to just migrate one VM from one hypervisor to another because of like these incompatibilities, because of the scheduling configuration. We are working on an extension to OpenStack Nova API that would help the DRB service to test its decisions against the against the configuration of OpenStack Nova. Basically, DRB will be making certain assumptions and will be calling the API to say, okay, if I want to do this migration, will it work or not? Or would you suggest another place for this VM? Something like that. That kind of communication will be happening between DRB and the compute service. And this will help DRB to become aware of the availability zones that you have configured in your OpenStack cluster, and of course the compute service configuration in terms of the initial scheduling of the VMs. Well, ideally, we want this API to become a part of the big OpenStack. So we will be working on contributing this code back to the upstream, so it will become available to everyone. And if you want, you might implement your own DRB service probably. There's also plans to have some ongoing, improvements. For example, adding support not only for OpenStack as a virtualization platform, but also other. For example, Kubernetes. It's one of the recent virtualization solutions introduced in the open source world. So yeah, we want to look into making DRB work with this as well. Of course, we want to contribute the new this extension for OpenStack Compute API back to the upstream, definitely. But well, again, keeping up with the times, we think that artificial intelligence can be put to a good application here, right? What do I mean? So it could be that a trained model could make better decisions around the virtual machine placement than the Python Python modules or Python straightforward Python scripts. Ideally, that could help to identify specific patterns of the CPU consumption, for example, that are typical for your particular cloud, right? And that the decisions are being taken by DRB would be, in accordance to this, your specific best practices. Of course, AI could help us make decisions not based just on a single metric, but multiple of them, multi-dimensional decision making, taking into account not only the CPU, but all kinds of parameters that exist. But it is just a bit of a further planning that just trying to excite you guys about the possibilities. So the demo, let's get to the most interesting part of it. Just to a bit of a spoiler alert, it's a pre-recorded demo. Why? Because originally it would have taken me just maybe 15 minutes to get the load distributed, to get the cloud into the state where it demonstrates the imbalance of the load, right? So that I could show that how the DRB actually works. So to save your time and myself effort talking during this waiting time, we decided to record a video and cut it, make a cut basically. So what are we going to be showing? Have a small MOSK cluster deployed. It consists just of 2 hypervisors, just 2 compute nodes. Again, a smaller setup makes it easier to demonstrate. I will be using Mirantis Lens. It's very nice graphical user interface that helps you manage Kubernetes clusters and any objects in Kubernetes API. And just as a reminder, so MOSK is based on Kubernetes. It's every service is a container, and everything is controlled through custom resources. So I will be using Mirantis Lens to configure DRB itself, the service. I will be using OpenStack dashboard, aka Horizon, to create a bunch of VMs. And I will be using the Mirantis Stacklite Grafana dashboard, which is built like one part of the Mirantis Stacklite, to view the metrics collected from the cluster to basically see how the load is distributed. First of all, we'll do some configuration of the DRB. Very simple one. You can do the same like in your own cluster, in your own environment, and get things working. Then I will spin up a bunch of virtual machines that will be doing nothing, just sitting there, consuming almost no resources. Then I will look at the average CPU load of the hypervisors, just for you guys to get used to like this Grafana dashboard. And then we'll trigger one of the VMs to start generating the load on the cluster. After some time, well, the load will hit the threshold on one of the hypervisors, like 80%. And from that place, we'll just watch DRB to start making decisions and actually executing them. So balancing the cluster, bringing it back to the balance. Okay, so let me share my screen. So we are starting with Lens. That's how Mirantis Lens look like. And it's already connected to the MOSK's underlying Kubernetes cluster. So let's just see what services are there. As you can see, MOSK consists of tons of, thousands of pods of all Kubernetes containers managed, configured by single orchestration logic. And actually, our DRB is the DRB Cloud Kubernetes Operator is just one of these pods. There it is, right? The DRB controller, as we call it. And if we are going to look at the decisions that it makes, you need to bring up, of course, the pod logs view, right, to see the messages that the DRB service produces. Right now, it just does nothing. It just sits idle because, it doesn't have any configuration provided. It just sitting there, eating no resources, nothing. So we need to create a new custom resource named DRB config, right, for it to start working. So yeah, we don't have any DRB configs yet. We are going to create a new one. Okay, new tab and create resource. Yeah, so any kind of custom resource in Kubernetes needs to have some metadata associated with it. So you can reference it further. You need to provide the kind, you need to provide the API version, things like that. Well, obviously the name of the resource so that you can again reference it, and the namespace. So every Kubernetes, every MOSK has a bunch of namespaces in it, so that you need to make sure that the custom resource goes to the right namespace. And there comes the most simple and the most basic configuration for DRB that you might get. So you can define the reconcile interval. That means basically how often the DRB will be looking at your cluster and trying to make some decisions. Well, it's 300 seconds by default in this case. And also we need to provide some default configuration for the components of the DRB collector. Yeah. What type of collector is going to be used? In our case, that's the only one that we have is the Stacklite. The decision-making mechanism, the scheduler, right? The default implementation is, optimize the VM. Well, it's just the code name, right? You can add your own name. And of course, the decision executor, the thing that executes the decision that the scheduler makes. So how we're going to move the VMs around, we're going to move them with OpenStack live migration mechanism. Done. that's the basic minimum that you need to have to make DRB work. It will just automatically pick up the new resource once it gets created. And let's see what happens next. Okay, yeah, it started the logic, great, but it will still do nothing. Why? Because there are no instances on the cloud. There's no VMs. So yeah, it found 2 compute nodes, but no VMs on them, so there is nothing to optimize. Let's switch to OpenStack Horizon. That's the typical UI that your cloud user would see. All right. First of all, we need to log in. Well, we're logging in as a super administrator because we want to see hypervisors and a lot of additional metadata. Let's see what instances are there. No instances at all. And I mean, even globally in the cloud, not only in this project. So we have 2 compute nodes. All right, 2 of them. Just these. And well, as I said, no instances in any project are running right now. Good. Let's create a bunch of them. Let's create a bunch of instances. We'll be using the standard Cirrus Linux image that is shipped with MOSK, or you can download it from any kind of a cloud. Yeah, this one is Cirrus 6. It's a simplistic Linux, which is usually used for testing. We're selecting one of the flavors that we want. We can select anything. Like the flavor defines the size of the VM, like how much memory and how much CPU this VM is going to get. Right. And well, other parameters as well. So, okay, we need to plug the VMs into the network. It's not necessary, but well, just something that you would probably be doing in real world. We're plugging it into the admin network, waiting a key pair, like to SSH, and we're adding a special script, which gets injected into these VMs, and this script actually handles the generation of the CPU load. It's just like some tool that creates like a fake load. Right, and pretty straightforward. It just uses the standard utilities. Right, yeah. CPU, was it? Yeah, okay. Don't remember the exact name. So yeah, and every VM gets such a script inside. Great, but it will be doing nothing from the beginning, so we will need to trigger it explicitly for it to start generating the load. Okay, let's give the VMs a bit of a time to spin up. Since the Cirrus Linux is pretty small, it will not take a lot of time. And let's see the login monitoring alerting dashboard that shows us the load on the cluster, specifically the metric that we'll be trying to optimize. We call it node load 5, so 5 minutes average of the CPU for each hypervisor. So we have 2 hypervisors, and these 2 lines, they represent the current state of a particular hypervisor. Right. It's a percentage of the load. Yeah, not too high, nothing really to worry about as of now. Since the VMs are not doing anything, they're all active, but just sitting idle, so no load is generated. Let's take a look at how the VMs are distributed across the hypervisors. It's probably interesting. So as I said previously, OpenStack Compute Service, or aka OpenStack Nova, makes decisions where each VM needs to go, like when it's spawned, and it decides to what hypervisor to put every particular VM. So we can see that 3 of our VMs went to hypervisor number 1, and we'll just 2 of them to the second. Okay, great. So we'll just go, yes, and make this demo 5 instance. Oh, sorry, demo 5. Yes, that was demo 5 instance to start generating the CPU load. how we're going to do this. We need to log in into the virtual machine through the console. This is like a virtual terminal, virtual console that you get in OpenStack Horizon. You need to do a bit of a, clicking for it to start catching up the command line. Yeah, okay, yeah. The default login service and yeah, scoops go or as a password. Sorry, yeah, made a typo here. Apologies. Okay, so let's then trigger this VM script to generate the CPU load rate. There we go, and it tries to load all the virtual cores that it finds on this machine. It just puts that, like, some fake operations on it, and well, it's supposed to make the hypervisor feel not well because of that. And we're also doing the same for the second VM, right? Just to make the hypervisor really overloaded. Yeah, takes a bit of clicking, sorry. It's how the console works in OpenStack Horizon. It needs to hook into the keyboard events. Normally, I would be just SSHing. Right, and starting up the CPU load script as well. Boom, yeah, 2 cores. And let's see what happens next. Yeah, list of instances. So, and we'll immediately notice that the load on the first hypervisor went slightly up. Well, not that much, just 30%, but it's growing. So, well, it takes time for the virtual machines to actually load the real hypervisor, so the real physical stuff, and this is where we actually made a cut, like cut out some time to save you waiting. And well, let's see. Okay, so the DRB seems to have caught up with the new stages. So it sees 2 compute nodes and it sees 5 instances of them. It collects the metrics relative to these virtual machines and hypervisors. Yeah, and still does nothing because, well, the load is, well, less than 80%. So why bother? Let's give it a bit more time. And, well, sleeping for 300 seconds. So it starts growing even further. And a bit of a cut. And a bit of another cut. There we go. So after, well, it has taken us how many? Well, roughly 10 minutes to actually load the full hypervisor up to, well, 80, 83, 84%, I think, of average CPU load. Yeah, and because, well, we were not just collecting the immediate metric, we are just actually averaging it across like 5 minutes. So yeah, that makes it necessary to actually wait till it goes really, really high. Okay, what's going on here with our dynamic resource balancing service? It has started noticing something, yeah? You see? Yeah, and found one node with a more than 80% load, okay? And, well, found a bunch of virtual machines that it thinks it can move around to actually achieve the optimum. Yeah, it's overloaded, and, well, we're making decision to move these instances to another place and executing decisions, as you can see, like on the bottom. Right, yeah, 2 decisions to execute, and it started executing them. And now it's like time to talk to the OpenStack API and actually trigger the live migration for these instances. And this is done by the actuator server part of the DRB, and we'll see how it goes. Yep, as you can see, so a bunch of virtual machines, they got moved around. So demo 5 was left, I think, intact, but demo 4 instance got to another place. Right, and the load goes down because, well,
we kind of rebalanced the cluster. So it's now balanced again. Give it a bit more time. Yep. More or less equally loaded. Well, if we wait a bit more, they will be almost there. Yes, exactly. So the cluster is balanced again. This is how the DRB works in action, like real life behavior. So let's just do a bit of a summarization here. Key takeaways for the session. Mirantis OpenStack for Kubernetes provides a dynamic resource balancer service, which performs one of the key functions of VMware vSphere dynamic resource scheduler service, which is automated load balancing. That means automatic migration of the virtual machines to optimize the average performance of the cluster. There are also other functions that VMware DRS does, but they're implemented in other components of MOSK. Why? Because OpenStack is different from vSphere in the ideology and how it's built, architecture. So Mirantis is offering dynamic resource balancer service at no extra charge for all MOSK customers. So if you're installing MOSK, you will get DRB automatically out of the box at no additional fees or charges, as opposed, for example, in VMware case. Well, will you have to purchase a separate subscription? Well, a bundle. And Dynamic Resource Balancer service is available in MOSK starting from 24.2 release, which happened on July the 8th. At this point, I would like to thank you all for your attention and provide you a bit of a heads up on the other upcoming webinars. Soon we'll be holding, in August, we'll be holding 2 of them. A webinar dedicated to the best cloud native languages to build infrastructure as code in your environment, and also a session around Kubernetes security and state compliance. I think that is it. Thank you once again for your time. And well, if you have a question maybe afterwards, feel free to drop me a message. Just go to the mirantis.com website. There is a contact form. You can basically write a question for Artem Andreev, and I will pick it up. No worries. Thank you, and have a nice rest of the day. I hope to see you soon in our new upcoming webinars in August. Goodbye.